The last presentation will be online. It's Benoît Bienfait of Alstom who will give the presentation via the Teams link, and I see he's already on the screen. Benoît, the floor is yours. We don't hear you yet.
Do you hear me?
Yes. Excellent.
Okay. Without any echo? Perfect. Good morning. My name is Benoît Bienfait, working for Alstom since a long time. I was involved in a lot of projects relating to railway systems, and more particular since 12 years now, I have worked on the ATO of ATCS, pushing the standardization process via programs like Shift2Rail. I've prepared this presentation with Benoît Bisset, who is possibly connected, I don't know. We have decided that I will present myself alone because it will take too many time if we have to share like that. But it has been done with Benoît. Benoît is a young engineer, but strongly experienced already in ETCS and ATO, working now on a Europe's rail program for Alstom. So today I will present you the outcome of the work, the joint work we have done with Sfera. The target we had was to achieve for the next TSI, we don't know exactly when, but next TSIs, we would like to have a common interface joining the IRS needs like you have today in Sfera and the subsets, the future subset supporting ATO up to Jouet 4. So there are three main topics we would like to share with you. The first is the outcome, which is the logical architecture, because basically our target was to determine interchangeable logical blocks with standard interfaces, including the most important one, probably the track train interface. The second topic we'd like to address is focusing on this track train interface interoperability principles and solution we are now proposing in the architecture ATO up to Jouet 4. Then we will focus a little bit on the exchange data to give you an idea on the way we are going to, because it has to be continued in the context of Europe's rail, hopefully with the Sfera members and the X2Rail 4 members. And finally, there will be a conclusion. So if we enter in the logical architecture, you can see here the current situation for the logical blocks at system level we have achieved. On the top here, you have a lot of logical blocks relating to the trackside fitment. And on the bottom here, you see all the logical blocks which are related to the onboard applications, including ATO and DAS. So I will go through this smoothly by the migration plan. Just a word before to go inside this architecture. These are the design criteria we have chosen since the beginning to build this architecture. We have first the interchangeability. It was very important for the users to determine logical blocks which can be supplied by different suppliers. The flexibility is the second design criterion. Flexibility means that the logical blocks you can see here are fully interchangeable, but it is not forbidden to implement several building blocks in one cubicle. It is application specific according to the needs of the application and the customers. So the logical block may not be split, but there can be several physical architecture candidates with different type of implementation in several cubicles. The third criterion was incrementability. We wanted to have something which permits to go smoothly from the current situation in Greater Automation 1 to the Greater Automation 4. And finally, the extensibility, the architecture you will see, the intention was to have something permitting to manage at least the track train communication independently from the application. It's not a solution for ATO nor for DAS, but the idea was to determine something that could be used also for other applications we even don't know today on board, permitting to upgrade quite easily the track train solution, always remaining interoperable. So the first level of this architecture, which is incremental, I will not focus on the track side, just you have to know that for the track side we have here the traffic management system and also the train management system. Train management belonging to RU, traffic belonging to IM, infrastructure manager, and they share the necessary information for the onboard application via these 4 databases. The first one contains the missions. So when the train will wake up, the first thing it will ask for the mission. That could be the driver, or could be also the automatic system. And the mission indicates which IM you have to contact and which train running number, the reference train ID, you have to use to have access to the timetable. The second database contains all the train data sets, which are necessary if you want to make data entry of the ETCS or of the running stock. Each time you change the train composition, you have a new train data set, which is delivered in this database. The third database contains what we call today the journey profiles, a concept that you know already very well in DAS applications, indicating the next stopping point, passing point, and so on. And finally, we have here the segment profiles, the track plan data extracted from the digital map, giving the object definition, like the valises and all the object units already today for DAS and ATO applications. One new concept also for GeoE4 is the dynamic part of the segment profiles. You will see all the objects are determined here in the static part, like for example the signals. The aspect of the signals are given by this channel here with dynamic segment profile. It will be more clear later on, hopefully. So this slide indicates what is happening if you have a great rotation 1. Only the ETCS onboard, which is represented here by the train protection. ETCS track site is here, ETCS onboard is here. And a localization building block permitting to localize the train without balises like we have today. And so we would have a repository, a system here, permitting to connect and to acquire all those data coming from the track side to fulfill the need of the localization which is necessary for the ETP. The second stage is the DAS application, where we are in GeoE1 plus these instructions given to the driver. And so the idea is to have one building block here, which is coming from the Sphera reflections, with standard interface here, permitting to connect with the repository. The track train interface is here, you will see more detail later, and all the data which are necessary, like today in the IRS for the Sphera application, could be transmitted here. This is a mandatory interface, like the interoperable interface also. Then you have also optional interfaces. The first one with the localization. If you want to have the benefit of these interchangeable modules supplied by somebody else, these positioning information are accessible optionally. Another optional interface is the 130 interface, which is already specified in the TSI 2023, giving access to the safe envelope computed by the onboard ATP. If you use it, the DAS indication, the speed profile, can immediately take into account this safe envelope, avoiding to display something non-consistent to the driver. And then the last optional interface is this one with the rolling stock. Of course, the DAS application does not control the traction and brake system, but all the information given by the rolling stock to the ATO world, ATO DAS world, I would say, can be used also optionally, taking into account the current degraded situation of the TCMS. So this interface, 139, is already specified and is part of the TSI 2023. So it can be used by the applications of Sphera. The next step is the Grid Automation 2, fully compliant with the TSI 2023, with the same architecture, the same spirit. Just here, you have the ADM module, which is in addition to the DAS application controlling the traction and brake chain via the 139 interface. The other interfaces are fully mandatory for the GeoE2 application. The next step is Grid Automation 3 and 4 up to GeoE4, where you add here one building block, which is a perception building block, collecting all the sensors like cameras and so on, detecting the obstacles, also the environment, things which are not directly in the gauge but in the environment, and also permitting to read the signals. We will see that later. These are the the eyes and the sensors of the driver. It replaces the eyes of the driver. And then another module here is the APM, replacing the brain of the driver, receiving the event detected by this perception building block. So this interface C8 is fully standardized for the plug-and-play interface, interchangeable. And in addition, this APM is using the information coming from, additional information coming from the running stop, giving once more the current situation about the health of the TCMS, permitting the APM to know what are the limitations to be observed to protect the train. So you can, sometimes you will have to be requested to stop immediately, to stop before given amount of kilometer or time. This is something given here. And finally, you have here an interface with the ATP, because the obstacle detected by the perception building block and treated by the APM are sent in an ETCS language, I would say, permitting the ETCS to adapt the movement of authority according to this new type of obstacle. Today, we consider only the track circuits to detect obstacles. Then here we have additional information. The next step, and last probably, is to read the signals. The signal states are sent to the signal converter, permitting to operate in areas which are not fit for ETCS trackside. Just we give via this interface packets like ETCS level 1, permitting the ATP to protect the train, even if the trackside is not fit for ETCS. So this is an overview of the incremental approach. You have here the design criteria already mentioned, and here there is a summary that you can read later on about these building blocks I just mentioned before, and with the incremental approach for this greater automation. Now we can focus on the interoperability solution and principle based on the concept of repository as I mentioned. If we use the same incremental approach in greater automation 1, we have only the ETCS trackside and onboard. Via this subset 26, the onboard ATP is able to protect the train against overspeed, for example. And for the rest, the driver is the only boss on board after God, receiving the missions to be operated from the RU, his boss, on paper-based or tablet, it depends on the customers, and the driver is managing this task himself manually according to this paper-based solution. The train characteristics are also given to the driver when he starts his services in such a way that each time there is a change in the train composition, and at least when he starts his service, he has to make the data entry, for example, of the ETCS using this train data. So it is safety relevant. Then he has the driving experience, and for the timetable, he has also access to paper-based or tablet or something like that, informing the driver about the current timetable to observe. So if there are some changes in the paper-based information received, so he has a connection by telephone with the RU control center. The data entry is made using the train characteristic mentioned before, and the moment authority is deduced according to these. And if there are changes in the timetable, the journey profile in this case, and the timetable information, then we have also a connection with the infrastructure manager control center. This is the situation of today. In GA2, compliant with the TSI 2023, we still have an ATO on board, ETCS, everything the same. We always receive the mission profile on a paper base, the train characteristics also on a paper base. If there are changes, there are connections with the RU control center. The data entry is done like before. And the novelty in the TSI 2023 is that we have this connection, like in Sphera IRS, connection with the IM transactor server to request and receive journey profiles going from A to B. In the journey profile, you have the list of segment profiles to be used, and these segment profiles you request to the trackside and you receive it with the appropriate version. You know that very well. It is the current situation also for the IRS. Now, if we are going to the, and this is the 126 interface that you know very well, or the IRS, which are quite close at the end of the day. If we go to the GOA4, we still have the repository here, managing these informations. replacing the driver. There is possibly no driver at all. When the train is waking up, the first thing it will do is to connect the home server belonging to the RU. For example, if it is a French train located in Germany during the night for any reason, this train will connect with the server, the ATO transactor, the train management transactor belonging to SNCF, SNCF.fr for example. He requests for a mission and he receives the missions. It is completely digitalized, no more paper. Even if the train will be operated at a given time in GA2, the driver will receive this information in a digital way. Then the second thing the repository will do is to request the train data set according to the train composition mentioned in the mission profile to permit to make the automatic data entry of EDCS. Then, having received the mission profiles and the train data, in the mission profiles you receive also the contact information of the appropriate IM. If you are located in Germany, even if you are French, you receive a contact information of DBNets, and you use this contact information to open a connection with the transactor belonging to the DBNets. You get the journal profiles after request. In the journal profile, you get the list of segment profiles with the appropriate version, most up to date, and if necessary, you request this segment profile and you receive. And one thing more, in this connection from OE, you received also, as soon as you have received a journal profile, you will receive the dynamic part of the segment profile, so the current status of all the objects, like the singers, for example, in real time. And the ID was to have an evolution of the 126. Today, in the 126, like in IRS, you have some packets like journal profiles, segment profiles, and so we are now working to extend, to update the subset 126, defining the new concept that we have discussed also with Sfera, like the mission profile. Okay, so the next step is just to summarize the scope of the repository. Repository becomes the keystone of the architecture in the future, not only to supply information to DAS or ETO, but the idea is to use the same mechanism to supply information to all other applications on board that could request some data coming from the trike side. And so the scope of the repository is to request and receive the mission profile and journal profile.
5 minutes.
Pardon?
5 minutes.
5 minutes. Okay, thank you. So to check the version and consistency, to check the consistency between the journal profile and the information received from the signaling system via ETCS, to have a safe path from the current train position, to store the past segment profile, and to have the reference location in one dimension, and to place the data in each segment in the unique reference location. You can read it also carefully. We can go to the third point very rapidly, just to give you an idea. We are working now on the definition of all the detailed data inside this packet, mission data, train data, segment profile data, and so on. What I would like to share with you is that the idea is to have a layered approach with a common topology profile, just to cut the track line in pieces, linear pieces, and each segment profile here, common topology profile are segment profiles, I have an ID and a version. And for each segment profile, we have different layers. One of them would be the driving profile, supporting the data in the IRS and in the subset 126 to fulfill the need of the driving system. Then we have the signaling profile with the signals, the geometry profile with all the micro mapping, permitting to detect and to localize the train, but also to detect the gauge of the train, the ego track. So the idea of layers permits to, if you have new applications, to define new layers with the same mechanism containing the data which are necessary for the new application. If we focus on the one layer driving profile, we cover here all the data which are currently in 126 and in IRS. Voilà, this is a slide indicating that the digital map supplies the static part of the segment profiles, and the dynamic part of the segment profiles are given by the traffic management system For example, the aspect of the signals. In the signaling profile, the signals are defined by digital map in the segment profiles, and their state is given by the dynamic part of these. Voilà. I will skip the other because we are going into many details here, if you agree. Just going to the last slide to summarize what are the achievements of this common work with Sphera. First, a common vision on the architecture and the interoperability principles, including new concepts like mission profiles. A proposal of a new data format. As you know, probably in the subset 126, we use binary format. We have worked with Sphera to go more in a more readable format like XML or JSON. And there is now a proposal which is made to be decided at the end of the day in Europe's Rail. There is a concept paper for the communication management, how to get the appropriate contact information for the appropriate server, to make that the trains are belonging to air use, are operated by IAMs, and are also crossing borders. So everything is managed here, explained in this document. And there is also a concept paper for the mission profile, determining all the tasks, all the activities that are mentioned in the mission profile as coming from the air use responsibilities. For the next steps, it will no more be in shift to rail, of course. We are now, all of us, going to Europe's Rail, and the next step will be to continue to detail the data content for these four concepts: mission profile, train data set, journey profiles, and segment profiles, with a static and dynamic part. And this is a work to be continued in Europe's Rail, hopefully involving the Sphera people and the, I would say, the other people coming from X to Rail 4 in a similar manner. Voilà, Bart. Thank you for your attention.
Thank you. Thank you, Benoît.